In this video, we're going to talk about hurricanes, how they form, what they look like, and what kind of damage they can cause. So first, where do hurricanes form? Hurricanes form pretty much anywhere on Earth between 5 and 25 degrees north and south. Now, of course, if they're not in the Atlantic Ocean, they have different names, like typhoon, but I'm going to use hurricane in this video. Now, you'll notice that some parts of the Atlantic in 25 or 5 to 25 north are in hurricane territory, but some parts of the Pacific near the United States are not. Why is that? Well, it depends on the temperature of the water. And the water off the coast of California isn't very warm, and hurricanes need warm water to form. Now, over here in the western Pacific, you can see there is plenty of warm water over here most of the time, and so you can get hurricanes in the north and in the south. Of course, called typhoons instead. Now, what is the definition of a hurricane? So, to be a hurricane, you have to be two things, and same thing for typhoons and cyclones. First, you need a minimum of 75-mile-per-hour wind. If it's not at least 75 miles per hour, it could be a tropical storm or even a tropical depression. Two, hurricanes have to form over water. And then three, they have to be a low pressure system. They can't be related to a front. That would be something else, like a thunderstorm or a squall line. And so those are the minimum requirements for a hurricane. Now, obviously, hurricanes can go much faster than 75 miles per hour wind speed as well. Now, hurricanes are big. Some of them can be up to 350 miles across. And like I said, they're a low pressure system. So the lowest ever pressure recorded with a hurricane is 882 hectopascals. Compare that to an average sea level pressure of about 1,100 hectopascals. So that's about 87% of normal air pressure. That's a lot of air that's missing from when a hurricane runs over an area. Now, that low air pressure is actually what allows those fast winds to form, and it's actually what brings up that moisture from the ocean, which fuels the hurricane. So, that moisture from the water rising up and condensing powers the hurricane, and then the low pressure allows even more air to rise up. It almost fuels itself. Now, in the northern hemisphere, because of the Coriolis effect, hurricanes spin counterclockwise. In the southern hemisphere, they obviously spin the other way, clockwise. So you can always tell what hemisphere a hurricane or typhoon or cyclone is in based on which way it's spinning. So this one's counterclockwise, that's going to be northern hemisphere. Now, the minimum temperature for a hurricane to form, 80 Fahrenheit, 26 Celsius. And there's a reason for that. Without that warm water, there's not enough moisture and not enough heat to allow that water to condense in the clouds upwards and drive the hurricane. So if it's cooler than this, if a hurricane runs over cold water, like let's say the coast of California, which has 50 to 60 degree average water, it will actually dissipate the hurricane. And it'll become a tropical depression or maybe just a strong low pressure system. So the warmer the water is, the stronger the storms can get. And the opposite is true. The cooler the water it is, the weaker the storms will get, or you won't even get a tropical storm at all. So you can see in this picture, this is in Celsius. The water off the coast of the United States and the Gulf of Mexico is upwards of 30 degrees Celsius. So definitely warm enough to form a hurricane. You only need about 26. So anything hotter than that, you can get a hurricane with. So usually this happens during certain times of the year. Now, raising up that question of could you stop a hurricane? Well, if we look back at the temperature, you need a minimum temperature to get a hurricane. If it's not at least that temperature, you can't get a hurricane. So you might think maybe you could drop ice in the ocean or cool it down with an iceberg or something. Well, turns out it's really hard to stop a hurricane. There's probably better ways to, evacuate the places that hurricanes are going to get hit with. But theoretically, if a hurricane ran over land or ran over cold water, that would be one way to stop a hurricane. Naturally, obviously, it's kind of hard to make the ocean cold. But yeah, so since hurricanes are powered by warm water, if you were to make the water cooler, that would be one way to stop it. Now, what decade has the most hurricanes? So, maybe you've heard of hurricanes in the last 2 decades since they're pretty prevalent. But actually, it's not the last 2 decades. So it's not the year 2000s or anything like that as far as decade goes. Now, the number one year for hurricanes and tropical storms, that'd be 2005. 28 storms and 15 hurricanes, with some pretty strong ones that hit that year, which we'll see a little bit later. But the biggest decade for hurricanes was actually 1940s. So the 1940s, they had an average of 25 storms every single year for that entire decade. And if we look at this graph, we can see that, decades for hurricanes and tropical storms, they sometimes go up, they sometimes go down, they sometimes go way up. There's the 40s right there, and then down and then up again. And there's the most recent decade, at least for this data. So 2010 to 2020 isn't quite on this graph yet. You can see it varies. Now, there is a time of the year where hurricanes are most likely to happen. It's not always the case. Sometimes you get hurricanes outside of the hurricane season, but hurricane season is August to October. And the reason it's in the later summer and fall is the ocean gets warmed up and then stays warm for a long time, for months. And so during those warm months of at least the ocean, even if the air is cold, the hurricane can still be formed. Now, as far as damage, let's talk about damage in the U.S. 2018, how much damage did the U.S. have in dollars versus, let's say, 2009? Well, here's the crazy thing about hurricanes. It's very dependent on where they hit and how strong they are. So in 2018, there was 2 hurricanes that hit the U.S., and it was $55 billion in damage, quite a bit. In 2009, only $125,000 in hurricane damage. So what's going on here? Well, sometimes a hurricane never hits the coast of the United States at all during a year. That seems likely for 2009. Sometimes hurricanes will hit, but they won't hit certain areas, or they don't have a strong storm surge. It just depends. Now, as far as total damage over the United States, so this graph right here, this map, shows you how many billion-dollar weather climate disasters have hit the United States and their cost. Now in red, dark red, 200 billion for those states. In light pink, like Nevada, 5 million to 100 million in damage. Now, what I want to bring to your attention is, of all the disasters you can think of, except earthquake for some reason is on here, all the disasters in the last 40 years together cost $1.8 trillion. If we look at tropical cyclones over here, those alone were 1 trillion of that. So hurricanes and tropical cyclones cause over half of all billion-dollar disasters in the entire United States. So they're pretty much the number one damaging storm or any disaster in the entire country. So they're kind of important to know about, be prepared for, and plan when they do hit. Now, to rank a hurricane, like you kind of want to know how strong they are, we use the Saffir-Simpson scale. So you might have heard this before. They rank them from 1, 2, 3, 4, 5. Anything below a 1 would actually be a tropical storm and not a hurricane. And there is no above 5 because anything greater than 155 miles per hour wind is still a 5. And it's actually pretty rare to get a Category 5. There seems to be an upper limit for the strength of hurricanes, like they can't get too much faster. So I think we've got a pretty good scale over here. Now, if you're looking at the wind speeds between a Category 1 and a 5, it's about double. So Category 5 is about twice as fast as a Category 1 winds. And if we look, only about 10% of hurricane deaths are caused by wind. So if it's not wind, what's causing damage? Well, with hurricanes, it's storm surge. So storm surge causes most damage for hurricanes. Now, storm surge is about 50% of all deaths and probably most of the damage. We're talking upwards of 80% of all damage caused by storm surge or flooding in general. So with Hurricane Katrina in 2005, they had up to 28 feet of storm surge from just that hurricane. And what it basically is, if you don't know what storm surge is, if the average sea level was at here on this little diagram, when a hurricane comes in, it pushes water towards the coast and it raises up the level of the water. So almost like the ocean was getting higher or the land was sinking down into the ocean. And especially for Hurricane Katrina, parts of New Orleans were already below sea level. So twice is not good when it comes to storm surge. So let's actually take a look at Hurricane Katrina in particular. So it was a Category 5 at one time. It did drop down a little bit right when it hit the land. So not Category 5 when it made landfall. But like I said, up to 30 feet of storm surge, and New Orleans is already below sea level, so not good when it overtops the banks of the levees. So let's take a look at some before and after pictures. So on the left we have before, and on the right we have after, and you can see water fills in all of the low areas with storm surge. Now for these big structural buildings, yeah, they withstood the storm surge and stayed standing. But for smaller buildings, like you would think there would be a McDonald's here, there wasn't one anymore afterwards. So it can wipe away poorly constructed or even wooden constructed buildings that were, well constructed. If there's 30 feet of water and that water is moving, it can destroy a lot of things. Let's look at another image. So here's a highway system, and you can see all of the low level ground flooded. All these houses on the left, they weren't flooded before, now they're underwater. And this was taken days after the hurricane hit when it was calm enough to fly a helicopter. And so you can see storm surge, lots of areas flooded, thousands and thousands of acres of land and houses and residential areas flooded. So that is the number one damaging thing when it comes to hurricanes. And as we can see up here, 85% of the entire city was flooded. And it wasn't just New Orleans that got hit by this hurricane. There were parts of Mississippi that got hit by this hurricane as well. So hurricanes are huge, over 350 miles across in some cases. So don't just think it's one city that gets hit by these things. They often hit large parts of the country. Now, what happens once a hurricane does hit land? So when a hurricane hits land, remember, hurricanes are powered by that warm water and warm air that's rising up into them. Once they go over land, there's no longer that warm water anymore. And so without a supply of warm water, the low pressure can't pull up warm air. And then instead of getting updrafts, you get downdrafts. And then it rains, cools down, and the storm dissipates. And so this is a track of Hurricane Rita. You can see the hurricane made landfall and then immediately became a tropical storm, tropical depression, and below that. And that rain doesn't just dump all right on the land where it makes landfall. A lot of that rain just keeps traveling up the country. Because of the westerlies in the United States, it moves from west to east, and sometimes it even makes it back out to the Atlantic Ocean all over again.